This is the last video of the tutorial series to create animated illustration. The process of creating the character, background, and some additional animations will be introduced. Select the character, and create a new animation clip. Connect the mesh group. No modifier has been added for the animation yet. Select the mesh group, and add the Transform by Animation modifier from the Modifier tab. Select the animation clip again. You need to add two timelines. Add a timeline that controls control parameters and a timeline that links to the Transform by Animation modifier you added right before. Set the length of the animation and turn on the loop option. With the Transform timeline selected, select the Bone tab and press the All Bones to Layers button to register all the bones as timeline layers. Select the Control Parameters timeline, and register all control parameters as timeline layers. If any keyframes have not been created, you can create keyframes in batch by pressing the Add Keyframes to All Layers button. The initial value of eye blink is that eyes closed, so I changed the value. Select the Transform timeline and make the animation by modifying bones. Press the Start Edit button to turn on the edit mode. After moving the time slider, press the Add Keyframes to All Layers button to add the keyframes. Rotate the bones slightly to transform the character's posture. Animations using illustrations are generally composed of repetitive motions with little change in posture. Likewise, in this example, I will also make the character move slightly without taking a big action. It will vary from person to person, but I recommend that you make the character's posture repeat some patterns. It is recommended that the character repeatedly move up and down, or repeat some poses where the body is tense or relaxed. Make 2 or 3 postures that are the basis of the animation repeated over and over again. Let's copy the created pose. Select one timeline layer and click the Pose Export button in the right UI. Set the name of the posture to be saved, and select which bones to save. In this case, select all bones and save the pose. Move the time slider to the location where you want to copy it, and then press the Pose Import button to select the saved pose. The saved posture is duplicated and applied. Let's modify the copied posture a bit more. When you completed several postures, select the Root Unit menu. Select the animation clip and activate Autoplay. When you play the animation, you can see the character animating. Execute the bake and let's check the results in Unity Scene. When you run the game, you will see the character move as the animation plays. There are still many remaining processes. If you have made the main poses, let's try distributing keyframes. If the keyframes for a posture are located in the same frame, the animation may look awkward a little. The animation is much improved if the movement changes sequentially from the body to the arms and legs, or vice versa. However, it is recommended that this is done in the latter part of the animation production as much as possible, because the keyframes are scattered, which can complicate the UI. Copy completed postures. When copying multiple keyframes, it is convenient to select common keyframes at the top of the timeline UI and copy them while holding down the Control key. If you have a lot of keyframes, copying may take some time. Modify the copied postures a little bit more. I tried to create a motion that is emphasized in the animation. It is quite effective to make a certain point in the animated illustration to be emphasized. In this example, I created a motion in which the character stretches arms. You can improve the quality by modifying animation curves. Then it's time to animate the robot arms. You can make the robot arms look three-dimensionally using the assistant bones. I want to make it look like the character is manipulating the robot arms. To do so, make the robot arms move at the same timing as the character's motion. When a character stretches her arms, the robot arms is also stretched as well. It is good to use assistant bones when the robot arms are pointing up or down. The basic postures of the robot arms are created. When you play the animation, the character and the robot arms move together. I modified the animation to improve the quality of the animation. I edited the assistant bones more. The robot arms are modified to move larger. The mechanical movement can be expressed by modifying the animation curves. I modified the animation timing of the robot arms. They usually move a bit slower than the movement of the character. Because the concept is that the character controls the character move first, and the robot follow the character's motion a little later. Now that the animation of the robot is completed pretty well, let's modify the animation of the character again. The most emphasized part of this animation is when the character folds the arms and stretch them, the robot arms are also stretched. In this part, I improved the timing and pose of keyframes better. Let's execute the bake process and play it in the Unity scene. The motion of the character has been completed as intended. It is showed that the robot arms move heavily according to the character's movement. The basic work of the bone animation is over. We still have a lot of work to do. The next task is to make the animation using control parameters. Select the control parameters timeline, and let's modify the eye blink first. Blinking is very fast, so the value must be converted within 1 or 2 frames. If basic keyframes of blinking have been created, duplicate these keyframes. Makes the character blink at a modest time. It is also quite effective for the character to blink the eyes. Next, edit the breath layer to let the character breathe. After adding the keyframes, gradually increase the value of the breath control parameter and decrease it. The body direction layer is associated with the character's posture. Move the time slider and set the body's direction according to the character's posture. It is recommended that you first create the animation using bones and then edit the control parameters associated with the morph modifier later. This is because you can edit precisely with control parameters and morph modifiers while viewing the completed posture. After pressing the play button, you can see that the control parameters and the bones play together. Let's continue editing for other layers. Next, edit the head direction and hand grab layers. In the same way as editing the body direction layer, let's edit them considering the timing of the character's posture. If the value of head direction is changed, the head of the character will be rotated. Setting the value of hand grab changes the appearance of the left or right hand. Next, I modified the eye direction layer. Controlling the eye direction control parameter changes the direction the character is looking at. Referring to the value of head direction, control the character's gaze. Let's play the animation and check the results so far. The character's head and upper body moves naturally with the morph modifier added by the control parameters as well as the bone animation. Moving the head and upper body while the character blinks and breathes further upgrades the animation. The next step is to control the fingers of the robot that are probably the most fun in this video. In the previous video, I have created the robot's fingers to behave like 3D models by control parameters. Edit the finger layers to create motions in which the robot's fingers move. Let the robot's fingers continue to move without stopping. At this time, it is good not to move the fingers at the same time, but to move with a little time difference. Just as you can see in the timeline UI of the video, you can place the keyframes sequentially. Now that the animation for the left robot arm is complete, let's create an animation for the right arm in the same way. When you play the animation, you can see the animation of the robot arms moving nicely. The character's animation is almost complete now. The rest of the work is on the ancillary parts such as the skirt of the dress and hair. Let's take a quick look at the process of creating a skirt motion. You can move the bones of the skirt and make them flutter up and down. At this time, you can use assistant bones and use the scale tool. The skirt is not fluttering only to the left or right, but it looks like it pops out forward. You can also copy keyframes using the pose export function. Select only the bones that correspond to the skirt, and then paste the posture using the time slider to the proper position. When making an animated illustration, it is also good to move a little bit exaggeratedly. The skirt of this red dress with the robot arms is the largest part of the character. Therefore, people's attention will be concentrated on the movement of the skirt, so it is better to exaggerate them more. In the same way, let's make a motion that hair blows in the wind. The skirts and hair have a very similar animation production process. It will take quite a while because there are quite a lot of bones, but let's make one by one. Although skipped from the video, animations of the character's belts, bracelet, and necklace have been created. The more detail you can make, the more wonderful your animation can be. Making the animation of the character is complete. The arms of the robot move according to the character, and the heavy and hard fingers act like a machine. Detailed points such as the character's gaze and the head's direction make the animation look cooler. Once the character animation is complete, let's create an animation for the background as well. In the Any Portrait editor, select Buildings. I want to add a moving fog effect here. I added several fog images that I prepared in advance. Fog images were drawn as a white fog image on a black background for an additive blending. Create individual meshes for fog images. Create a mesh and set the fog image. Press the Reset Vertices button to create vertices in a rectangular shape to fit the image. Creates meshes for other images as well. Select the mesh group, and add fog meshes. Press the plus button and select a fog mesh to add. Select the added mesh and change Alpha Blend to Additive in the Shader Setting property. Turn on Edit Default Transform, modify the size and position of the fog, and change the default color. Change the order of the layers to determine which objects are fogged. Add and place other fog meshes in the same process. Placing fogs between buildings make that the background looks deeper. Place 2 or more fog meshes in the same location. This is for creating an animation in which fog meshes appear alternately. Create a new animation clip. Select the mesh group again to add a modifier. Add a transform by animation modifier. Select the animation again, and add the transform by animation modifier you added right before as a timeline. Set the length of the animation, and turn on the loop option. Select only fog meshes and add them as a timeline layer. Turn on the edit mode for the animation and create keyframes. Now, let's make the animation that fog meshes move sideways while they appear and disappear. In particular, the fog meshes at the same depth must be shown up alternately and disappear. Add keyframes and make meshes move sideways. Set the alpha value and modify animation curves so that the fog appears and disappears. When the fog mesh disappears, make another fog mesh appear. Let's complete the foggy city animation in this way. Select Root Unit, select the animation and turn on the Auto Play setting. After running the bake process, open the Unity scene. The separate fog meshes I have created earlier in the tutorial have been hidden already. Place the character again so that it is slightly covered by the fogs. Changing the Z per depth setting or increasing the scale of the Z axis makes it easier to place. With any portrait, you can also create simple screen effects. Let's make that the animation starts with a state of a dark screen. Create a new portrait in the Any Portrait editor, and load the black image. Create a mesh and create vertices by pressing the Reset Vertices button. Create a mesh group, register it as a root unit, and attach the mesh you created. Resize the mesh and add a transform by animation modifier. Create an animation clip, connect the mesh group, and add a timeline. Sets the length of the animation, but do not activate the loop option. Add the mesh as a timeline layer and make the animation. Create the animation in which the transparency of the black image is reduced from 1 to 0. Select root unit, turn on the autoplay option, and execute the bake to the Unity scene. Place the black mesh at the most front of the camera to fill the screen. Now it is really the final step. When you create an effect like a handheld camera, the illustration's animations look more dynamic. In this part, I used Unity's animation feature instead of an Any Portraits. Open the animation tool from the window menu and create the anim asset while selecting the camera. Create keyframes by adding the position of the transform. I created an animation in which the camera periodically moves up and down. All production is over. Let's look at the completed animation. Nice animations created using Any Portraits features, Unity's screen effects, particles, and etc. have been completed. With Any Portrait, you can animate your own illustrations, as well as for games. Our team looks forward to your wonderful works. Thank you for watching for a long time.